Dear students, welcome to the video lecture series on Vocational Electronic Science. Today's topic is network theorems. This presentation is created and narrated by Hemant Satpute, teacher, Department of Electronic Science, Fergusson College, Junior Wing, Pune 4. In today's lecture number 2, we are under network theorems, we are going to cover up Kirchhoff's laws. In Kirchhoff's law, we are going to discuss Kirchhoff's current law, KCL. Reference used for this presentation is Special Notes for 11th Bifocal Electronics, written by Professor D.S. Vidyasagar, Department of Electronic Science, Shri RLT Science College, Akola. Let's begin. Kirchhoff's current law, KCL. Let's see what this KCL states. Kirchhoff's current law states the algebraic addition of all the currents in a closed circuit is always equal to 0. It gives us the idea of sign convention of currents in a circuit. To be precise, the algebraic addition of all the currents in a particular node in the circuit is always equal to 0. So let's define a node. So the node is a point in a circuit to which at least 3 or more than 3 wires or branches are connected. To understand KCL, let us study the following circuit given in figure number 7. In this circuit, there are 4 resistors R1, R2, R3 and R4 which are connected in parallel with a battery of 12 volt. Also, there are 6 nodes, that is node A, node B, node C, node D, node E and node F as shown, because at point A 1, 2 and 3 currents they are meeting, out of which one current is coming in to the node, another 2 are going out. Similar is the case for the other nodes. Observe that the potential difference across all resistors is same because the resistors are connected in parallel. So potential difference will be equal to 12 volt. So we can calculate the current flowing through each resistor as follows. So current through R1 will be equal to I2 is equal to the applied potential difference or potential difference across R1 divided by value of resistance. So 12 volt upon 1 ohm, that is 12 ampere is the current I2 flowing through R1. The current through R2 will be equal to the voltage across it 12 volt divided by value of resistance 2 ohms. So 12 by 2, that is 6 ampere is the current flowing through R2 and that we have named as I4. Current through R3 will be equal to I6 and that is 12 volt divided by 3 ohm, that is 4 ampere. The current through R4, resistor R4 will be equal to, again same voltage is available across R4. So 12 volt divided by 6 ohm and that is 2 ampere. So the total current that must be delivered by the positive terminal of the battery will be I is equal to I2 plus I4 plus I5 plus I6. So this I will be equal to I2 plus I4 plus I6 plus I5 and then sum comes out to be 24 ampere. So the current coming out of the battery will be equal to 24 ampere. Now this current of 24 ampere splits in 2 parts at node A. I will be equal to I1 plus I2. Some part of this current of 24 ampere will go through R1 and remaining part will be going towards node B. That is 12 ampere and 12 ampere because total is 24 and we have already calculated I2 as 12 ampere. So 12 ampere will be going further towards node B. Then the current I1 of 12 ampere splits into 2 parts at node B. One will be flowing, one I4, part of I1 will be flowing as I4 which is 6 ampere through R2 and remaining current of 6 ampere will flow towards the node C. Then the current I3 splits into 2 parts at node C this 6 ampere will get splitted as 4 ampere flowing through R3 and remaining 2 ampere flowing towards R4, that is of 6 ohm resistance. Now these currents again meet at nodes D, E and F to complete the circuit. In this way, it is clear that the total current of 24 ampere delivered by the battery is returned back to its negative terminal. Now at node D, what happens? 2 ampere is returned from R4 and 4 ampere is returning from R3. So total current 4 plus 2, 6 ampere is coming out of the node D. At node E, 6 ampere is coming from node D, 6 ampere is coming from R2. So total 12 ampere of current is going from node E to node F. At node F, 12 ampere is coming in, 12 ampere from R1 is coming in, and total of 24 ampere is going out of the node F and it is returning to the battery voltage 12 volt. Hence total supplied current is equal to total return current. The KCL, Kirchhoff's current law, finds large number of applications to analyze the complicated electrical and electronic circuits. The general equation of Kirchhoff's current law is given by summation I equal to 0 at a particular node. In other words, incoming current is equal to outgoing current. That's all for today's lecture. Stay tuned for the next lecture in the series. Please do visit my YouTube video channel FYJC Vocational Electronics for all the video lectures on different topics in this series. Subscribe, like, share and stay tuned.